Hello, welcome to this video. We'll do 1 to 7 questions. Those want classes, you can inbox me. GCE and G12 classes are on. Therefore, we have a question which says, question 1, a sample of pure compound is heated after it's been heated until it is completely molten, and the compound is then allowed to cool until it's completely solid again. The graph shows how the temperature of the compound changes with time. So, which of the following shows points when the compound exists in both liquid and solid states? Now remember, it's a solid, it's been heated, becomes a liquid, some form of, again it's cooled and goes back to what? To solid. Now, this type of change does not just occur from liquid to solid. It has to pass through two phases. So there will come the intermediate phase here, which is going to have both solid and liquid. So at least from NO here is a solid. Okay, then OP here, at this particular point here, it has got both solid and liquid. Then here PQ, it's solid again. So OP is the answer. The diagram shows one of the methods used to separate what? Mixtures. The above method is, this is decantation and not filtration. I know you wanted to put filtration. There is no filter funnel here for it to be called filtration. Just decantation. Which gas is not obtained on a larger scale by filtration? Which gas is not obtained? Is not obtained by large scale? Language and fraction distillation. So here, of course, the answer is ammonia. Ammonia cannot be obtained by fraction distillation. Argon, nitrogen, oxygen, these can be obtained at large scale. The key point here is large scale. So ammonia is not obtained by large scale. Question 4. A mixture of salt and iodine crystals was heated for 20 minutes as shown in the diagram below. What is R and S? R, after heating this a mixture of salt and iodine crystal, you need to know that it's going to melt. Okay? It's going to melt, and the iodine can sublime, can change direct from, for example, solid to gas, and it can also condense in the heating funnel there. Now R, like I said, the iodine can sublime, so R is a sublime, is a sublimate, like I said. Then S is the residue that has remained, so it's a sublime. Iodine can sublime, and when it sublimes, it sticks there. Okay, solid like. A5, graphite and diamond are allotropes of carbon. By now we must know what allotropes are. Allotropes are atoms of the same compound, with same properties, with same physical properties, but they have different, with same chemical properties but different physical properties. Which of the statements below gives the correct meaning of the term allotropy? Allotropy is just when two atoms exist, but these two atoms, these two elements, they're coming from the same same element. So it's the existence of different forms of an element, but in the same physical state. Like I said, they have the same physical properties, but different chemical properties. So the answer is B. Existence of different forms of an element, but in the same physical state. For example, those are carbon. A6. The table below gives data about 4 substances. Which substance has particles in a disordered arrangement at room temperature? Now, melting point, boiling point. Now, when you talk of disordered arrangement, you are talking of at a liquid, of course. Liquid or gas. Gas can also be in a disordered arrangement. Now, disordered arrangement can only occur at very low temperatures, and A is the answer. Question 7. At which temperature does a concentrated aqueous solution of sodium chloride begin to boil? At which temperature does a concentrated aqueous of sodium chloride begin to begin? Now, sodium chloride is an ionic compound. Ionic compounds, they've got high melting points, so they require a really high temperature for them to start boiling. So the answer here is D. Thank you so much. I'll see you in the next video. Can you contact me for GCE classes or grade 12 classes revisions? They are on very affordable price. Thank you.